Hi, good evening, everyone. We'll be starting in next 2-3 minutes. Today's session is on array and data structure.
And different types of data structures and tables. So basically, I won't be covering tables. Tables are not much used these days. So I'll be concentrating more on the latter part, which is arrays, data structures. Okay. So as everybody knows, an array is a series of elements with the same data type. So when I say an array, it's not like in other technologies. In IBM AS400, when I talk about an array, it would be having the same data type across that array declaration. So if there is an array which is a days of the week, and it is declared as character, then all the elements, whatever the dimension would be, 7 days, 20, 15, whatever it is, all of them would be of the same data type. Okay. So basically, an array is a series of elements with the same data type, whereas data structure would be a different scenario. Data structure would be having different subfields of different types. So when compared to an array has the same data type across all the elements, but in data structure we would have different data types declared within. Okay. And basically, there are three types of arrays when it comes to iSeries. There's a compile time, runtime, and pre-runtime. So basically, I'll go with the runtime first. So runtime is what gets declared empty or initialized in the program and can be modified and can be used inside the program as and when required. Okay. So if you see here, this is an array. This is a runtime array, which is declared with a varchar of 20 characters, and the dimension is 12 because this is for the months. And I can use that by providing an index of that element. So in AS400, the index begins with 1. When compared to other technologies, it begins with a 0, but here it begins with 1. And I can give the index hard coded the way I've done here, and then I can start manipulating or populating the array with the values that we want to populate. So for the first element of this array, the dimension provides how many elements would be there inside an array. So here we have provided there would be 12 elements in that array. The data type would be a character data type. The same way we can have a numeric data type, and we can have a dimension given to it. Okay. And we are going to populate values one by one the way I have done here for all the elements. Whenever you're going to populate a value for an array for which we don't have an element, we would get an error. So if I try to populate a value for 13, we would get an error saying that this element or this value cannot be added to this dimension or this index because this is not available. The declaration is just for 12 and we are trying to populate it for the 13. So array index out of range error would be displayed on your screen. So this is a runtime array. We declare it as a normal field with a data type. We provide a dimension and we initialize it to make it clear that it is a blank, and then we start populating the values to the indexes one by one. So this is an example, that's why I've done it in series, but you can populate as and when required in the programs. Okay. The second way of having an array using a data structure. So this is a data structure array where we have a data structure named months, and we haven't given a field name because we don't need that field name, because we would not be using that field name. And what I've done is I have done initialization, and then I've declared an array inside the data structure that points to the first position of month, and the first position is having January, the second, and it would be till 20 characters, and then the 21st would be having February. So this is how this declaration works. Okay, so now name is a part of the months array having the same data type the way I have declared here. Okay, and the dimension is given of 12 because I have 12 initializations here, and it is beginning with the position 1 of this data structure. So this is another way of declaring an array. Okay, if you want it to be there for your runtime. So instead of populating this way, you can populate this way as well. So these are two ways of having. So if I remove this, okay, if I remove this, what I'll have to do is then I'll have to do a qualified name of month dot name. Okay, I can show you in the code. Okay, I'll quickly copy this to show, to demonstrate how we can do that with an array. So I'm going to make this as month. Okay, and I'm going to remove this initialization. And now I don't have to provide a position because I don't need a position. Okay, I have initialized this data structure. Whenever you're declaring data structures, any fields, make sure you initialize them. If you don't initialize, you might run into some problems of garbage values inside your arrays. Okay, so I'll just copy this again, and I'll replace it with dot name. Okay, so I've initialized them. What I'm going to do is I'm copying this indexes again so that I have the correct indexes. So this is another way of using a data structure array. This is a normal array, and this would be a data structure array. So in here we have the data structure qualified to the array name, and then we have the indexes. This is one another way of having a runtime array inside a data structure. And this was the earlier version where we had the array populated by initializing non-named fields by declaring it with star n, and then giving an array that points to the first position of the data structure. Okay, so this is for runtime array. Then we'll jump onto a compile time array. So runtime arrays can be modified in the runtime. We can populate them as the program proceeds. For compile time, that has to be declared at the bottom of the program. So the array should be declared while you are developing the code itself. So all the elements should be inside declared with a two asterisks and a CTDATA keyword, and then the name of that array. It is a good practice that you provide a name so that when you have more than one array, you understand which points to the which declaration points to which array. Okay, when I'm declaring that, I have to make sure that I provide a ctdata keyword on that declaration of that array. So here we have declared months named array, which has a varchar of 20. The dimension is 12, and it is a compile time compile time array. So ctdata is the keyword that we have to provide over here, and then we have taken an index over here. Okay, and this is just a for loop that I have here. I would be having this on one of our systems in case you want to go ahead and test this. This current IBMi system that we have is having this. I will share you the details of this system. You can go ahead and review the code and also execute it and debug it to understand how it executes and how the array gets populated during the runtime. Okay, when we are providing a runtime array, we cannot give a blank space at the end. So your program should terminate for how many elements are there. Okay, so if you provide one blank space, the program would not compile. It would assume that there is one more element. There are 13 elements you have declared in the compile time array, but your declaration has only 12 dimension declaration. So make sure that whenever you are having a compile time array declared, you don't have an empty line or a blank line at the bottom. So this is a compile time array. Okay. Now going to the next one. This is a compile time array, and there's an alternate array declared to it. So we have months and then we have a date. So when we are declaring compile time array, we have to declare the array with the keyword of ctdata. And when we are declaring an alternate array, for that array, we have to use the alt keyword, and then we have to provide the array, which is going to be used for this array's alternation. So this would be the primary array, and this would be the alternate array for this array. Okay. And what we have done is we have declared the months as 10 characters. So this is 10. And as soon as the 10 ends, we have the next two characters, which is for the months. And that we have declared as a packed decimal of 2. So the dimensions have to be same. For the primary array, as is going to be a compile time array, we have to provide a ctdata. For the second array, we have to provide the alt array, alt keyword, and then we have to provide the array name. Okay, so this is for the compile time array. So these are the two different ways we can have a compile time array. One is having a plain compile time array, and the second one is a compile time array with an alternate array associated with it. Okay. Then we have the pre-runtime array. So pre-runtime array gets populated before the program starts executing. Okay, and the pre-runtime array has to be from some other external source. So in this case, whenever we have to have a pre-runtime array, we have to provide the keyword as from file. Now this declaration is not allowed in all free format. That's why I have to go with the fixed format, fixed free format. Okay. Here we are providing the table name. Okay, so I'll just go ahead and do a run query. And this is one single record, okay, that has all the months in it. And every record is a fixed size of 20 characters. So this is how the record is declared in that file. Now we have declared that file and we have to provide the length. So while declaring the file, we have to make sure that we have it declared in this format where and show you. So this is the file type. So here it is going to be an input file where we are just going to read it, and then the file destination, sorry, so file destination would usually we keep it blank, or we make it full procedural when we are going to take control. But in this case, we want to make sure that this is going to be an array or a table. And for that reason, we have to make sure that we declare it with a T. So here we are going to make sure that this file that we are going to use for our pre-runtime array is going to be considered as an array rather than a table. And while we run that, okay, while we run the program, it would read this file for the first record, and it would have a dimension of 12 with per record would be of 20 length. Okay, and every row would have 12 records, and the length of every element would be 20. Hello, does anybody have any queries, questions? Hello, am I audible?
Uh, yes, you're audible. I think someone has misspelled something. No, you can continue.
Okay, sure. So this is the array that gets loaded. This is the array declaration, okay, where we have to have the keyword as from file, and then we have to provide the file name, which we are going to declare in the file specification. Okay, we have provided the length of every record. Every record would be of 240 length, and that 240 length record would be distributed in chunks of 20 20 length, 12 chunks. So 12 elements of 20 length. So yeah, and the dimension is 12. Okay, this is how that array would be declared, and we are using an index to just run this for loop and display every element inside that array. So this is a pre-runtime array. I'll just come out of this. Now let's move on to the data structures. Okay, so as I said, a data structure would be a set of would have set of subfields, and those can be of different data types. Okay, so in this is a personal information data structure. This is a template that I have declared. Okay, and it has different data types. So the first name, the last name. So we see the lengths are different. The data type is different. So here we have a packed. Here we have a packed. The rest are varchar. Then we have his date of birth as a date. Okay, this is a data structure that has subfields, and every subfield can have a different data type. Okay, what we are doing here is we are populating every subfield with a certain value in it. Okay, so here we are providing the date. This would be his birth date, and the data type over there is date. So we are converting this string of 1989 1022 to an ISO. So while converting, we are suggesting the person date built-in function that this is a string in an ISO format, convert it into a date type, and move it into this subfield of the personal information data structure. Where we don't want to move anything, we have moved blanks. Here we are moving numeric values. Here we are moving character values. So most of them are character, some are numeric. So we have different data types used inside the same block, and same block is used here. So this personal information is the array, sorry, is the data structure that we have declared, and here we have declared it with a like ds of the same array that we have declared the template of. So this is the template, and using this template we have created this data structure. Okay, I have declared the same data structure again, but here you see that there is a difference of initialization, and I'll jump onto that real quick after I'm done with this part. Now this part is an array of the same personal information. So now this has a dimension to it. So I can have a data structure with a dimension which would work like an array, and we can have subfields inside it. Okay, and that can populate a maximum of 20 different personal information group. So this data structure is having a dimension of 20. This would work like an array. The way we have an array, this data structure will also work like an array. I'll quickly see if I think I have this. I'll debug this to show how it works. So I'm at the first statement, which is the LR is equal to on, and I'm just going to uh, evaluate the values in this data. So this data structure I have initialized. So while initializing, what it does is it initializes it with a default value. So these would be all the characters would be initialized with the blanks, all the numerics with zeros, and dates would be initialized with the default date. The time would be initialized with default time. So whatever would be the default of that data type, that would get initialized with the fields would get initialized with that data type's default values. Okay, now I'll quickly go to the next one. It is the same declaration, but I've just added an X and have removed the initialization. When I do this, you see here the date not initialized with the default value, and we have junks. So these are the junk characters that are available. So when we try to do some operation on this, if we are going to validate, say if personal info x dot zip code is not equal to 0, this is going to definitely fail, and you are going to receive a decimal data error, mch 1202, I suppose. Yeah, and that is the error that would blow up in the runtime. So whenever you declare an array or a data structure or any field, any standalone field, make sure you always initialize it. So this is just for an what we say an educational purpose that I am showing you, that if we don't initialize it, it would have junk, and if we try to without clearing those values or without resetting them, if we try to populate or we try to move anything out of it or try to validate it, it is going to blow up with a runtime error. Okay, so quickly going, I should have shown, yeah, I showed you the previous initialized one. Now I am going to show you what has been populated in this array. So in this array, we have populated the values. So we have the date, we have the zip code, we have the phone number, we have all alphanumeric fields, everything is available. So this is a data structure with multiple subfields, and every subfield would be having different data type. Now, as we had the excuse me, the second declaration, which was for an array, what we are doing is we are incrementing the index, and then for that index we are moving what we have populated till here. So whatever we populated till here, we are having that inside this, and we are going to move it inside here. Basically, I don't have, yeah, so this is an initialized data structure array. So this is for the first index, then the same would be for the second index. So as we have 20 index, we would be having this array is of 20 dimensions, so we'll have 20 indexes. 20 elements can be populated in there. Now what I'm doing is I'm incrementing the index and I'm populating the value that I have populated it here in the array. And now if I do and evaluate this array, you'll see that whatever was there in the normal personal info data structure has been now populated into the first element of this array. The rest elements would still be blank because we haven't moved anything there. So this is the example of data structure along with a data structure array. This is the data structure array which I have shown earlier. So this is just a revision part of it. This is how we can have a data structure array with an initialized field inside the same data structure. Inside the same data structure, we have these initialize. But here, if you see, I've made this as template. And when I'm using this on another data structure, I'm declaring another data structure like this DS, I have to make sure that I initialize with a star like DS so that these values that we have provided are also initialized in here. In case if we don't do it with a like DS, our data structure would get created with the same structure as this, but it would not have the values that we have populated over here. Okay, I can go with a quick example of this. I'll just repeat this and I'll make this as 1, and instead of like this, I'll just have it initialized. Okay, and I'll debug it to show. So these are the two declarations. This is the first. Here, as we have done the initialization with star like DS, the values have got populated. Okay, but in the case here we haven't initialized, so this would be a blank array data structure. Okay, so when we are declaring a template and we want the declarations or initializations that we have done in a template to take effect to your declaration of the data structure, make sure you initialize it with a star like DS keyword. With this, what would happen is it is going to pick up all the values that are declared during the declaration are initialized with the declaration part of this array, this template, data structure template. All the values that we have initialized will also take effect to this data structure. Okay. And this is just the display part. I'll just quickly run. It is just going to pop display all from January to December. That's it. Jumping on to the next one. Yeah. So here what we have done is we have taken a months info named data structure. We have made it qualified. And then what we have done is we have taken two fields. Okay. And if you look here, we haven't initialized here. As I say always that we have to initialize the data structure. We have not initialized it here. What we have done is we have initialized the subfields with the constant that we have declared. Okay, and what we have done is the field 1 gets initialized with month name, and the field 2 gets initialized with the month days. Here we have taken a standard length of, I think this is 10, so it would be a 10 length, and I have the total length of 120 characters. So 12 months, 10 of 10 characters for each month, so 120, and 2 characters for every number of days in a month for every month. So that's why we have 24 for this 12. Okay, so we are initializing these two fields, and then what we have done is we have overlaid the name of the month on the field 1 from the position 1. And at the same time, we have overlaid the number of days on the field 2 from the position 1, and we have given a dimension to it, and also given the character, also given the data type and the length of the data type. Okay, so we don't have to basically perform an eval of this to these fields. So what, while declaration itself, we have initialized it with the month name. Okay, so I'll just jump on to the demo part of it. So as soon as we jump on, I'm just going to initialize this. So here you see month info.name, all the 12 values are picked up correctly, and the field one has the string. The string version of the names of the months is available in the field one, and the array version of the same is available in the monthsinfo.name array. The same goes with the days. So the array version is month underscore info dot days. Okay, and the string version of it is available in the month underscore info dot field 2, and this gets initialized directly from the constants that we have declared inside the program. And this is basically again the same thing. It is going to just display the number of months from that array. Okay. The fourth example. This is a data area data structure. So what we have done is I have created a data area, and this is the data area that I've created. So what I'll do is DSP DTA ARA, and so this is the data area, and I have created it of length 120, and the data area is of type character. So this is the data area that has the string version of the names of the months. Okay, now going to the next part, what we have done is we have declared a variable which has a name as local data area. It's of 120 length, and what we have done is we have given the data area keyword over here, and for that data area keyword we have given the name of the data area that we have created. Okay, this is just a declaration. So as like the pre-runtime array, the values would not directly get populated over here. So for that, we'll have to do an in. We'll have to use an opcode named in, and when we use the opcode in, we have to provide the field name. This is the field that we have used for this data structure. This array. Now what we are doing is this array gets loaded when I use the opcode in. Once I have that values populated, I am moving that into the months underscore info named array. So this is the months info named array. In data structure. In this data structure, I have given the name as a subfield, which is an array starting from the position 1 with a character length of 10. Okay, we'll see how it works. So if you see here, this is not going to have any values as of now. Okay, the same goes for this months named qualified data structure array. Okay, now for those values to get populated in this local data area field, we have to use the opcode in. I think I don't have the library list added. Training. And now we should be good. So as soon as I do an in, the information from the data area gets loaded into this string, this character variable of 120 length. Okay, once that gets loaded, what I'm doing is I'm going to move that into the data structure array. So once that gets moved, you see that the values get populated in the data structure in the array. This is just the display part of this execution. Okay. And this is the last example where we have the indicator data structure, sorry, indicator data structure. So what we do is we define a standalone field. You can give any name to this field, okay, and you have to declare it as a pointer, and you have to initialize it with the address of *in. So we have to initialize with the address of *in, okay, and then the next declaration would be based on this standalone field, and then all all the indicators, as you know that RPG would be having indicators from 1 to 99. So you can declare them depending upon that position, whatever name you want to declare to that subfield, to that indicator you can provide. So usually it should be 3 basically. In most cases we have exit on 3, and then we would have a cancel on 12. So this is going to work same as when you press an F12 on a screen, or an F3 or an F5 on a screen. So instead of using a *in 03 is equal to on, you can just validate using if exit is equal to *on, or if exit, if not exit, and it would take effect depending upon the current value that is available in this field, subfield of this data structure, which is based on the indicator DS named subfield, which is based on the address pointing out to the *in. So for compile time array, I'll just go on with those examples. So this is the compile time array. So these fields get directly populated during our compilation. So these fields initialize whenever we begin our program, depending upon the declaration as ctdata, which is for the compile time data area, that gets declared at the bottom. The values get populated as soon as we are done. The program gets initialized for the beginning. And this is just the execution part of it, where we are displaying all the 12 values from that compile time array. Here I am going to do or I can just missing one parenthesis here. Let's see. Let's move on with the second approach. This is fact. Sorry, I have to make it %char. Let's see if this works. And yeah. So this is how the alternate array would work. Okay. This is the pre-run time, and I have already shown you what is there in this file, but I'll run that command again. So this is how it is, and when we run this, so that this gets populated automatically. So we don't have any compile time declaration. This is directly from the file, and it has populated the values directly from the file. This is just the display part of this declaration, this array. As I showed, this is the runtime array. So runtime array is declared without any keyword, just the dimension keyword has to be provided. Okay, and initially it would be blank. Okay, and as I move ahead and start populating the values, it would have the values getting populated. And the same way as I showed, this is a data structure array which has initialization done with no field names, and an array is declared from the position 1 for the same length with the dimension, and we are now going to see the values inside this array. So this was from the data structure array. So this is all for the training part.
Hi all. So if someone have any query, then they can ask. So thank you for joining.